Good morning, students.
Good morning, ma'am. Good morning, ma'am.
Very good morning. We do the problems based on Bayes theorem. Yesterday we did this problem. No, na? Second problem we made, I hope. This completed. We have not done first problem. Correct?
Yes, ma'am.
Yes, ma'am.
We will go through the first problem. It is important. It has come in the final exam so many times. That means I told this time they have introduced conditional probability in third chapter. Before the paper name was 2013 pattern onwards, it has become decision science. Earlier it was statistical quantitative methods. That time in statistics it is there. Okay. Go through the problem, then we will solve. It is known that 15% of the males and 10% of the females in a town having equal number of them. Underline the word equal number of them. For example, 3 boxes are there, 3 identical boxes. In the final examination, if the question comes like this, okay, for first box, the probability is 1 by 3. For the second box, if 3 boxes, 3 identical boxes, then the probability is 1 by 3. Probability of third box, probability is 1 by 3. If you add, you will get 1. If it is identical boxes, there are 2 identical boxes. Then probability of first box chosen is 1 by 2. Probability of second box chosen is 1 by 2, like this. If it is 4 boxes are identical, then first box is 1 by 4, like that. Fourth box is 1 by 4. If you add, you will get 1. Okay? Here, why I told this? Okay. Equal number of them are unemployed. First, we have to identify the variables. We have to identify the variables. What are the variables? What are the variables we have to identify? We have to identify the events. Here, in this particular problem, we are having male, female. It talks about unemployment as well as employment, correct? 4 events we have to identify. Here, first one, yesterday how we wrote dish A, dish B problem. The customer orders dish A. The customer ordered dish B. Customer is a man. M, we have represented the event name. Customer is a woman, W. Like that here, the person selected is a male. Write down. Steps are important. Person selected is a male. Similarly, female is there. Again, person selected is a female. Person selected is a female. Okay, then person selected is employed as well as unemployed. First, okay, here I am taking A complement. What is A complement? The notation is A does not happen. I told the notations yesterday. If you remember, I told the notation of A union B, A intersection B, A bar intersection B bar. That is neither A nor B happens. Here A bar, that means A does not happen. Here the problem talks about employment as well as unemployment. Okay, if you consider E as employment, then E complement will become unemployment. Then how we will write? Probability of employment complementary events formula. Probability of unemployment is equal to 1. Okay, then represent E as person selected is employed. Person selected is employed. The other one is complement of E, that is person selected is unemployed. Right now, you have identified the events. Then, here, probability that the person selected is male. That means it is half. Why it is half? Males and females in a town having equal number of them. Equal number, underline. That means Probability of the person selected is male is half, that is 0.5. Similarly, equal number of them. For that purpose, we are doing this. Half, that is 0.5. Then, after that, what they have given? 15% of the males are unemployed. Which event happened earlier? Males are unemployed. That means male has happened earlier. Correct? Then, probability of which event happened earlier? Male. Whatever the event happened, that comes in the denominator. Males, 15% of the males are unemployed. E complement given M is how much percent? 15%. That is 0.1. If you see the first question, the person is employed, they asked. The person is employed. For that purpose, we have to find out if the person is male, then he is employed. For that purpose, we have to calculate probability that the person is a male and he is employed. We have to calculate by using the probability complementary function. What is complementary function? Probability of A plus probability of A complement is equal to 1. Here what we are having here, male is unemployed. That means A complement is given. We need to find out male is employed. Here instead of probability of A, what I am writing? Male is employed. We don't know that. What is the complement? We know male is unemployed. We know that. That is equal to 1. This we have to calculate. Plus this is 0.15 is equal to 1. Probability of male is employed. That is equal to 1 minus 0.15, that is 0.85. Again, listen carefully. Person is a male and he is unemployed. He is given as 15%. 15% of the males are unemployed. The event happened is male, that's why it has written in the denominator. Male is unemployed, that is 15%, that is 0.15. In the first question, we are having person is employed. Person may be a male or a female. For that purpose, we have to calculate. We know that from the definition part, complementary events is always equal to 1. Probability of A plus probability of A dash is equal to 1. Here, male is employed plus male is unemployed is equal to 1 according to this formula. This value you know, right hand side is equal to 1. 1 minus 0.15 is 0.85. If you add these two values, you should get 1. Next. What is given next? Similarly, next also 10% of females are unemployed. That means which event happened earlier? Females are unemployed. That is given as 10%. Similarly, apply this. Instead of male, female. 1 minus 0.10, that will become 0.90. Females are employed. 1 minus 0.10. Similar terms we can apply. Then it will become 0.90. Till here, any query, students? Students understood? Next. The first question, what they asked, the person is employed. Probability that the person is employed. What is the logic here? Person is employed. Two possible options. The person is male and he is employed is one option. And he is employed. What we need to find out? Probability that the person is employed. We need to calculate. Person is a male and he is employed, or the other option is person is a female and she is employed. Two conditions here. Then how we will write? Male and simultaneous happening. Okay, he is employed. For employed, what event we have taken? E or addition. Person is a female, we have represented with F, and she is employed. Employed is represented as E. The first question is write down the probability that the person is employed. Set function, probability set function we have to write. What we will get finally? Probability of M intersection E plus probability of F intersection E. Okay. M intersection E. Which event happened earlier? Male has happened earlier. Then, if you remember the conditional probability, what is the formula for conditional probability? A intersection B, that is simultaneous happening of both the events. Initially, the event A has happened. How we used to write? Probability of A into which event happened earlier? A has happened earlier. The remaining event will come in the numerator part. Similarly, apply conditional probability. Which event has happened earlier? Male has happened. Probability of M into which event happened earlier? Male comes in the denominator. In the numerator, employment will come. Plus, similarly for second term also apply conditional probability. Which event happened earlier? Female is employed. Probability of female has happened. Then the remaining event is employment. Okay. You know the value. Probability of M value is 0.5 into E given M value. You know that is 0.85 plus probability of female value is 0.5 into probability of E given F is 0.90. Correct? Then 0.
Ma'am, can you go a bit slow?
Pardon me?
Excuse me, ma'am.
Just to substitute the values, huh?
Ma'am, can you go a bit slow?
Okay.
Yes, ma'am.
Okay. Again, I am repeating. Probability that the person is employed. Probability that the person is employed. What are the possible option? Person is a male and he is employed. The other option is person is a female and she is employed. Two conditions. Person is a male and he is employed, that is simultaneous happening of both the events. Person is a male, we have represented it as M. Okay. Employment, we have represented the event as E. That's why here we will get M intersection E. Next, or the other option is person is a female and she is employed. Female is represented by the event alphabet F and employment is represented as E. F intersection E. That means again simultaneous happening of both the events. Why we are taking intersection? Because person is a female and she is employed. Intersection. Then right now this is the logic behind the first bit. Then we have to convert this into corresponding probabilities. Probability that the person is employed, we have taken the alphabet as E, take it as it is. Right now, whatever the logic we have applied, take it into probability set function. Then we will write probability of M intersection E plus probability of F intersection E. Right now, conditional probability we have to apply. You know that the conditional probability statement says simultaneous happening of both the events, that is A intersection B. Probability of A into which event happened earlier, as our assumption is A in statement. Which event happened earlier? A. The remaining event will come in the numerator part. Similarly here, male has happened earlier, that's why probability of M into, okay, M has happened, that's why it comes in the denominator. The remaining event is E, it lies in numerator. Similarly, F intersection E, you write the same way. Female has happened earlier. Right now, whatever the values we got, we have to substitute in the formula. Clear, students? Okay. Then, this value is 0.425, 0.5 into 0.9, that is 0.45. Finally, we are going to get this value as 0.875. This is first bit. Next, second bit. Second bit can be solved by using two ways. Second bit can be solved by using two ways. One is by using conditional probability. Another one is by using Bayes theorem. Both the ways I will explain. Whatever you feel easy, follow that method. Here I will write these values. Probability of male is 0.5. Probability of female is 0.5. Okay. Then second bit. He is a male. Know that he is employed. Second bit. He is a male, known that he is employed. Okay. See, for example, in conditional probability, probability of A given B is there. I told 4 ways we can write conditional probability. Here, which event happened earlier? B has happened earlier. Probability of B. Then here we used to get probability of A intersection B. Okay, simultaneous happening of both the events. Similarly, here also we will write the same thing. Here M given E, that means the person is employed. We got probability of E, probability of M intersection E. This is equal to, already in the first bit, you have calculated probability that the person is employed is 0.875. Write down 0.875. Right now, see, this is M intersection E. M intersection E, you have written this way, and the value you got is 0.425. M intersection E can be written as, say, probability of M into probability of E given M. Okay. By using these values, you will get this value is 0.486. Or the other way, how can we solve this? Probability of M given E. Probability that the person is a male, correct? Okay. Here we use Bayes theorem right now. Instead of this, better to use Bayes theorem, it becomes easy for you. Okay, here what I told, Bayes theorem, inverse of conditional probability, that means numerator will become denominator, denominator will become numerator. Initially you write down this E given M. Which event happened? Male. Probability of male. Here only 2 events, that is male and female. Have you remembered the formula of Bayes theorem? What is Bayes theorem formula? An event A in conjunction with one of the n mutually exclusive and exhaustive events that it was preceded by the probability of EI given A is equal to, again here, inverse of conditional probability, A given EI. Which event happened earlier? EI, summation, I running from 1 to n, whatever the numerator you will get as it is. Here we are having male and female. Instead of summation I running from 1 to n, we will get summation I running from 1 to 2. What is that? Probability of male into male is employed plus probability of the female into female is employed. Students getting? Students?
Ma'am, can you explain once again?
A Bayes theorem statement, have you noted that an event A can occur in conjunction with one of the n mutually exclusive and exhaustive events, then the probability that it was preceded by probability of EI given A is equal to what I told. Bayes theorem is nothing but inverse of conditional probability. That means numerator will become denominator, denominator will become numerator. First write down that A given EI. Okay, here which event happened? EI. Write down that. Whatever the numerator, it will come as it is in the denominator with the summation I running from 1 to n in the formula, because n mutually exclusive and exhaustive events. In this particular problem, you have identified 2 events. Those are male and female. Here for that purpose, numerator we are getting the same value, the other event here 2 events, that's why it is summation I running from 1 to 2. 1 is for male, 2 is for female. Okay, here what does it mean? The person is a female and she is employed. Then substitute the values. Substitute the values in the formula. Okay. Probability that the person is male is 0.5. Here E given M is 0.85 upon numerator will come as it is 0.5 into 0.85 plus probability that the person is a female is 0.5 into E given F is 0.90. 0.90. If you solve this, you will get 0.486. Anyway, the problem you can solve. एक बार देख लिए ना सब लोग, go through the problem. Still, if you are having any queries, let me know. Till the time I will take the attendance. Yesterday also I was unable to take the attendance. Day by day, strength is deteriorating. Okay. Any query? Understood? Then we will go for another problem. Read fifth problem. Everybody read fifth problem. Fifth problem. Try to identify the events. Try to identify the events. Again, four events. Again, four events, students. What are those events? There are two identical boxes containing whatever it is, white and red balls. Here, four events we have to write. What are those? Event that the first box is chosen. F I am taking. First box I have taken F. If you want to represent it A and B, your wish, that is. Event that the first box is chosen. Similarly, again second box. There are two identical boxes. That's why I am taking first box and second box. S I am representing. Event that the second box is chosen. Here there are two identical boxes. The probability, the corresponding probability to choose first box is half. Probability to choose second box is again half because identical boxes are underlined. Okay, 0.5. Then what we are having? A ball is selected that is white. Correct? Probability that the ball selected is white. And in the problem we are having red ball also. Probability that the ball selected is red. Four events we have identified. Why we have taken, since box is chosen when identical boxes, that's where the corresponding probability is half and half. Then a box is chosen at random and a ball is drawn from it. If the ball is wide, which event happened? If the ball is wide, that it has chosen from first box. It has chosen from first box. Apply Bayes theorem. Apply Bayes theorem. Okay. For Bayes theorem, what is the formula for Bayes theorem? Inverse of conditional probability. Inverse of conditional probability, that is W given F, and probability that the ball is from first box upon, here again two events, so summation I running from 1 to 2, probability of F into probability of W given F plus probability, first we will write this, probability the white ball is chosen from the second box and probability of S. Probability of S. Then we need to calculate this value. We need to calculate this value we know, this value we know. We need to calculate this value. What the value we have to calculate? From first box, how many white balls? First box consisting of 4 white and 3 red balls. 4 white and 3 red balls. Sample space. Sample space is how much? 7. 4 plus 3. That is exhaustive cases. The totality of all possible outcomes of your random experiment. 4 white, 3 red. But total number of balls is, exhaustive number of cases are 7. Among those, I need to choose how many white balls? 4 white balls. Then 4 upon 7. 4 upon 7. Similarly, we need to calculate W upon S. The ball is white, it is chosen from second box. Second box. Second box consists of how many white balls and how many red balls? 3 white and 7 red balls. The sample space here 3 plus 7, that is 10. How many white balls available? 3. Means for this purpose we need to know permutations and combinations. Anybody knows the formula of NCR? NCR का formula? N factorial upon R factorial into N minus R factorial. What is permutation? Permutation is arranging the objects. Combination is selecting the objects. N factorial upon N minus R factorial. Okay. In this problem, 3 white and 7 red balls. Among those 3 white balls, we have to choose one ball in 3C1 ways, that is 3 by 10. That's why we will get 3. NC1 is equal to NCN is equal to 1. Actually, this should be covered in BRM 5th chapter, that is binomial distribution. Have you remembered this? Means maybe that is a different issue they didn't teach. How many students remembered? At least for exam purpose, some books you have read. Have you seen this formula? NC1.
Yes, ma'am.
A to the power of n minus 1 plus b to the power of 1 plus NC2 a to the power of n minus 2 into b square plus and so on. If I take NCR into a to the power of n minus r into b to the power of r plus and so on. This is called, here we are dealing with two terms. Here we are dealing with 2 terms, that's why 2 terms, that's why it is called binomial theorem. Actually, this should be covered in statistics, that is 5th chapter of BRM. If you gone through the syllabus, okay, here I wrote in 10th standard, we learned this as a binomial expansion, if you remember. A plus b whole to the power of n. This we studied in 10th standard as a binomial expansion. In BRM, instead of taking A and B, we used to take P plus Q whole to the power of n. Wherever A and B is there, it is replaced with P and Q. Why P and Q? Why not the constants A and B? Because in binomial distribution, P represents the probability of success, Q represents the probability of failure. That's why in binomial theorem, maybe if you didn't heard, listen right now, okay? P plus Q is equal to 1. Here also the total probability is always equal to 1. Instead of taking A and B, P represents the probability of success. Probability of success is always represented by the letter P. Probability of failure is always represented by the letter Q. P plus Q is equal to 1. Means किया क्या study किया क्या examination purpose point of view तो study करना चाहिए किया क्या आप लोग नहीं किया
No, ma'am.
नहीं किया okay फिलहाल के लिए अभी because next lecture I will take the expansion and all फिलहाल के लिए तो answer लिख लेना because only 1 minute is remaining. I will tell you next lecture. Please remind me, ma'am. Give us introduction about binomial theorem as well as permutations and combinations. Okay, students. Tomorrow's lecture I will explain because this is required for this. Okay, this is equal to probability of F is 0.5 into W given F half you take because these are in fractions. 4 upon 7 upon half into 4 upon 7 plus half into 3 upon 10. This is the answer for this problem. Finally, we will get 0.656. Highest mark in BRM आपके क्लास में किसको मिला था? Highest marks. How many marks out of 50 you got? Anuvinda? किसको मिला था highest mark?
मैम नहीं पता.
नहीं पता means at least highest mark out of 50, maybe 45, 46. Nobody got 48. I hope last year highest 48. Okay. Take this problem. Any query in this? Next lecture, just tomorrow's lecture, you remind me, ma'am. Give us introduction about